this video, we're going to continue solving equations and inequalities. In lesson 17, we are going to be looking at equations that involve factored expressions. So let's look at the word factored. The word factored basically means what two numbers make up a product. So if we have 2 times 2 equals 4, 4 would be our product, and 2 would be factors. So when we are talking about factored expressions, we are no longer looking at numbers by themselves. We are going to be looking at variables. So we could say x plus 2x equals 4. So what two factors make up the product 4? But because this is a sum, x and 2x cannot be factors, because factors only occur during multiplication, right? Two factors make a product. So what we have to do is we have to what we call factor the expression. And essentially factoring an expression is rewriting this addition expression into a multiplication expression so that we have two factors that make up a product. And in this case, what we would do is we would take the common factor here, which would be x, and then what we do is sort of a reverse distributive property. So in the distributive property, we have a variable or a number that we're going to distribute among all terms inside the parentheses. So we kind of want to do the opposite. We want to grab the terms that are in the parentheses and factor out, which means we would have to divide each term by this identified factor. So in this case, our identified factor, because it's the common term that occurs in both x and 2x is x, we're going to divide each term by x. So x divided by x is a 1, and 2x divided by x is 2. And so basically what we had here is x times 3 equals 4, or 3x, right? But now what we have is a multiplication. So we have rewritten this addition problem as a multiplication problem. So we no longer have the plus sign and we have the multiplication side. So I know in the beginning you could have said, I could have just combined like terms. Well, yes, you could have. You could have, but I wanted to illustrate the point because sometimes you won't have the same degree. Sometimes you will have x to the power of 2 plus 2x, and then you would have something different as your factors. But all we're doing when we're doing a factored expression is we are rewriting an expression with multiplication. So let's look at our first example. In our first example, we have 2x squared minus 10x equals 0. And in here we have to solve for x. Now before I do that, I have to factor out this expression. So let's go ahead and factor this expression out. We have 2x squared minus 10x equals 0. We're going to concentrate on this side of the equal sign right now so that we can factor it, because no matter how I change it, it should be equal to 0. So I don't need to do absolutely anything with this 0 right here. So I have to look for my common factors among these two terms. And what I notice is that I have two common factors. I'm looking at my coefficients. I have a 2 and I have a negative 10. Negative 10 is a multiple of 2 because the 2 times negative 5 is going to give me negative 10. But then I also notice that I have x's in both terms. Now, these terms have varying degrees. This has a degree of 2, this is a degree of 1. But I'm going to pull out 1x because it's the common degree. I begin my factoring by pulling out the 2x. So when I do that, I'm going to do the reverse distributive property. I have 2x squared. I'm going to expand this so you can see what is happening. Then I'm going to divide that by 2x. So when I do that, my coefficients cancel out and I'm left with 1x. And then I'm going to grab my next term, which is a negative 10x. Also divide that by 2x. And I'm going to have a negative 5 here. X divided by x is 1. So I've rewritten this expression in terms of multiplication. Now I'm going to go ahead and solve for x. Before I do that, I want you to pay special attention to this actual equation. I have 2x times x minus 5 equals 0. For any two numbers when multiplied together to be equal to 0, that means that one of these numbers has to be a 0. Because let's say this is a 2, 2 times 0 is 0. If I have a 2 times 1, I'm never going to get a 0. One of these numbers has to be a 0. So that is the zero product property of multiplication. So let's keep that in mind. Because even though I'm dealing with variables, I know that if I have this situation right there, I can assume that this is going to be a 0. I mean, it has to be for this equation to be true. The other thing that you need to notice, and this is not necessarily relevant in this particular example, but it will be relevant in future examples, is that you cannot divide by 0. So if you ever have an equation where you have 2x divided by y, you know that that cannot be equal 0, because this would give you an undefined. It would not give you a 0. So just kind of keep in mind the rules of the zero product property of multiplication. All right, so we have 2x and we have x minus 5. And we know, based on the zero product property of multiplication, that one of these has to be a 0. So I'm just going to split them up as I work through them, because I don't know which term is going to be 0, but I know one of them has to be. And I'm just going to go ahead and solve for each x here. And what happens when I solve for this one? I get that. So in this case, I know that it was the 2x that was 0. So let's go ahead and go back to our original equation and plug in our two values. If I want to substitute at 0 for x, you're going to find out very quickly that this, of course, is going to make the equation true. But what if I wanted to substitute the 5? Would that also make the equation true? So in this particular case, what we found out is that there are two values that will make this equation true. We have x equals 0 and x equals 5. So in this equation, both values are going to make the equation true. Let's look at this next problem. So we have these two terms. And if we're going to rewrite it as a factored expression, meaning we're not going to use a plus sign anymore, we're going to use a multiplication sign, then we're going to look for common factors among both terms. Now, this particular example looks significantly different than our first example, because in the second example, we now have a situation where it seems like attempts have been made to factor this expression out already, or at least the terms inside the expression. So when we look at the first term, we notice that we have x minus 3. And then in the second term, we also notice that we have the same x minus 3. My common factor is actually going to be a whole expression. It's going to be x minus 3. So just like I pulled this 2x in the example above, I'm going to pull out the x minus 3 as the factor. Now, when I take each term and divide it by x minus 3, you're going to be left with x in the first one, and 5, positive 5 in the second one. And then we know from the zero product property of multiplication that one of these terms has to be a 0. We just don't know which one it is right now. So let's go ahead and try to find